Hello, today I will introduce our work, an adaptive model ensemble adversarial attack for boosting adversarial transferability. Members of our teams are from Fuzhou University and Yuanzhi University. Now we begin to introduce our attack method. As for transfer-based attack method, it is often difficult to attack the target model with the adversarial example generated by the surrogate model due to the architecture differences between the surrogate and the target model. We calculate here the quasi-similarities between the gradients information output from each surrogate model. As you can see, models in the same family shows a slightly higher similarity, while the differences between the models with different architectures are very large. This leads to difficulties in attacking unknown target model with the adversarial example generated on surrogate models, which limited the usage of transfer-based attack in realities. Traditional transfer-based adversarial attack methods generally use data augmentation to optimize the process of generating the adversarial example to obtain more adversarial transferabilities. But they are very ineffective when the target model has wide architecture differences with the surrogate models, such as convolutional neural network and vision transformer. In order to generate more transferable adversarial example attack methods use multiple surrogate models to generate adversarial examples. But previous attack methods do not consider the characteristics of the surrogate models and directly example outputs of each surrogate model on average, which greatly inhibits the transferability of the adversarial example generated by ensemble attack. In this work, we propose adversarial ensemble attack method to address the problem mentioned above. We now introduce the framework of our attack method. Firstly, each surrogate model will predict the input images and output the predicted results of each surrogate models. Then the AGI module generates the corresponding adversarial example based on the output of each surrogate models. Use the adversarial example to attack other surrogate models for transferability evolution, and dynamically adjust the weight of each surrogate models in the ensemble attack based on the evolution results. For DIF modules, calculate the similarities of generate gradients of each surrogate model to each other and average them to obtain the disparity reduced map, which reflect which part of the gradients are more common and which part of the gradients are more different. In the last part, our method multiplies the output of each models by the weights calculated by AGI model to get the final output, which is then derived from the input image to get the corresponding gradients, which is then multiplied by the DF model to get the final gradients and generate the adversarial examples. In the experimental setup, our method outperforms the previous state-of-the-art method of ensemble attack method and can maintain the lead in the multiple combinations of surrogate models. We also conducted visual experiments, and we can see that it is difficult for the black box model to focus on the adversarial example generated by our attack method. Specifically, the areas of attention are smaller and more scattered, which shows that the adversarial example generated by our attack method are more transferable. Thank you for your attention. For more details about our work, you can read the full text of our papers and the release code of our attack method.